Okay, let me switch to my presentation. Okay, welcome everybody. Thank you for coming. I'm super excited to talk to you all tonight. My name's Jeff Williams. I'm the co-founder and CTO at Contrast Security. Oh, I'm on the West Coast right now, so that's why it's like getting towards evening. I've been working in application security since the 1990s. I started a consulting company to focus on security testing. I've broken into most of the large financial institutions on the East Coast, as well as done security testing for tons of major organizations, helped them start their security programs and so on. Lots of code review and lots of penetration testing. We'll talk a little bit about that. And I also started an organization called OWASP, the Open Web Application Security Project. And if you're interested in security testing, it's a great resource. They've got tons of incredible projects. I ran a bunch of open source projects there. Some of them have been extremely popular with millions of downloads a month. And I wrote a library there called the Enterprise Security API, where I did everything test first, very DevOps kind of project, tons of automated test cases. And it was, really, that was sort of my first foray into test first development, really liberating in terms of the flexibility that it gave us on that project. So I'm a huge advocate of both security testing and regular pipeline quality testing. And today I want to talk to you about using instrumentation as a way of testing software. It's an incredibly powerful technique. I want you to think of it as one of the tools in your toolbox and a tool that I hope you go to really frequently. But that's jumping ahead a little bit. Let's back up. So to start out, I wanted to just mention a little bit about my company. I was asked to put a slide in here. Normally, I don't talk about my company that much, but Contrast is an application security platform company. We provide a platform that helps companies build code that is secure. And I think security is just a subset of quality. And for the most part, you should use the same infrastructure to do security testing that you use to do any other kind of software testing. In most organizations, that isn't the case. In most organizations, security is very different from any kind of other software testing, and that's unfortunate. But really, software testing or security testing works best when it's integrated with the rest of development. I'll focus on DevSecOps because it's kind of the biggest trend towards merging those things together. But really, it's the same principle applies to any kind of project, whether it's DevOps or Waterfall or whatever. Security should be done as a part of normal testing. Anyway, my company provides a platform of tools and capabilities to help folks write secure code, make sure their libraries are secure, and also we work in production to identify attacks and prevent them from exploiting applications. So we really try to span the whole lifecycle from the first line of code all the way through operations. These are the 5 products we have, which are, we're not going to dive into here. We are moving into serverless, which is really interesting. If you're, looking for a cool new technology to hitch your wagon to, serverless wouldn't be a bad choice. We see many big organizations moving applications to serverless. So that's an exciting place to be. And we support a bunch of different languages: Java, .NET, .NET Core, Node, Ruby, Python, Go, and we've got some new languages coming out: PHP, Scala, Kotlin, and so on. Okay, so I wanted to start with the importance of application security. I've dedicated my career to it, so this stuff is, still actually surprising to me. I was going to say it's mundane to me, but it's not. It's still shocking to me how many security problems most applications have. The average application has over 30 vulnerabilities, at least 2 of them in open source libraries. That's a lot. If you were flying an airplane and they told you it has 30 safety problems, you probably wouldn't want to fly on that plane. But these kinds of problems are in the apps that you all probably use every day. Anybody here bank online? Cynthia, come on, I know you bank online. Everybody does.
I actually really try not to.
That's
I used to work
insane.
in financial services, so.
Wow. That's interesting. But what's crazy is even if you don't bank online, your information is still available in the systems that are accessed online. So it actually doesn't really matter. We trust our financials, our healthcare, our governments, our elections, our power systems. They're all controlled by the software that we write and test. And we're not doing nearly a good enough job at security. There's huge numbers of open source vulnerabilities, huge numbers of vulnerabilities in custom code, and the applications are under attack. The average application that Contrast protects is attacked over 13,000 times every month. So we're in a bad situation. Lots of vulnerabilities plus lots of attacks equals lots of breaches. And the ones you read about in the news are the tip of the iceberg. Every organization is being breached multiple times a year. We just did a big survey. The average is like 4 or 5 times a year they're getting breached. So, this is not good news, but it's not all doom and gloom. I think we've got a lot of good techniques that we can use to change this situation, but this is the situation that we're in. So today I want to talk about instrumentation. This is a technique that's been around for 20 years. Mostly people use instrumentation for adding logs to applications to get a little visibility about what's going on inside the application. But that's like the most boring thing you could possibly do with instrumentation. Instrumentation's an interesting technique outside of software as well. And you can see here, this is a product called the 9450, because the basketball court is 94 feet long by 50 feet wide. The 9450 is an instrumented basketball. As you play, it measures your dribble speed, the arc of your shot, your rotation on your shot, a whole bunch of other stuff. And you get a cool dashboard that gives you feedback on your game. I tried it and it told me I was shooting too flat. I've been playing basketball for 40 years. And it helps. It's an amazing thing when you can change from a sort of a coach to player relationship, from one where the players can do most of their own coaching with a ball that's instrumented. They can do their own drills. This thing comes with a bunch of drills built in, and the coach changes role a little bit from leading the drills and doing the day-to-day stuff to actually being more strategic and giving real strategic advice to the players. Same thing for healthcare. People on the call, you may be wearing an Apple Watch or Fitbit or something. You just instrumented yourself. Very soon, your phone is going to know you're sick before you do. And we can instrument software to radically change the way that security is done today, which is mostly expert-driven. You send your code over to the security team, and they do a bunch of magic stuff, find vulnerabilities. That's what I used to do, but I recognized I'm a dinosaur. In fact, I'm the problem because I'm slow. It takes a long time for me to test an application. I can't finish a pen test that takes 2 weeks during a build in a 15-minute pipeline. It's not possible. So we need to change the way that we do security testing to be much faster, much more automated, much more accurate. And instrumentation is the key to doing that. So here's how it works. As you know, in any programming environment, whenever you load the code from disk into memory, there's an opportunity there to instrument it. You add in some calls that, like, we call them sensors, that just snapshot the state of the application at certain points during the code. Very much like the way a profiler tool would work, or a tool like AppDynamics or New Relic work. They just monitor the running code and gather data, and then they analyze it and identify performance problems. Well, same thing here. As this code loads, we can add security sensors to it, so we can watch security-related calls and identify patterns of behavior that are interesting to security. So this code, the instrumented code behaves just as though you'd written these security checks into the source code itself and compiled it and run it. We're just adding these calls later because it's very difficult to get development teams to all add code to their applications, but we can add it dynamically this way. Everybody with me so far? Okay. So ultimately, having this instrumentation capability is not only useful for security, it's really useful for any kind of software testing, because now instead of just, throwing test cases at software, you really have a helper inside the running code that can watch how your code is running and make sure it's doing the things that you need it to do. So I spent many years pen testing applications. Someone once told me it was like staring up the shower to find a problem in the water heater. And it's like that because you're just, you're throwing these HTTP requests at an application and trying to trick it into doing something that it's not supposed to do. But it's super hard because you have to guess what's going on just by the output. You throw in a certain set of characters and you get a 500 error back, and you have to go, I think it must be not validating the data right. And this allows you to actually just see what's going on inside the application. So you can test things much faster and much more accurately.
Yeah. Sorry, Jeff, to interrupt, but so Peter had a question, which was how many snapshots created? Does the code need to be instrumented, e.g. the build process requires binding with the contrast libraries? So.
Right. So we do it all at runtime. And I could give a product pitch about contrast, and you could just use contrast and it'll find security vulnerabilities for you and analyze your libraries for you. But I don't like to give product sales pitches. This is not why I'm here. I'm trying to teach you about a technique for analyzing software. So I actually created a library called the Java Observability Toolkit that I'm going to use to demonstrate how instrumentation works. JOT will allow you to add your own sensors to applications so that you can see what's going on inside an application. I'll give you some examples of how you could use it, but really the sky's the limit. You can measure anything you want inside a running application, and you don't have to write any code. Like, that was my goal here, was to empower ordinary folks that aren't developers to do security testing and verify the properties of software by watching it rather than by writing test cases and executing them. Okay, so far, but the answer to your question is we don't have to compile anything into the application. We can instrument the application at runtime. So I'll show you how that works, but basically it's as the code loads, we're going to add those sensors then. And technically the sensors are just simple callbacks that we add to the code inside any particular method we're interested in. But we'll look at all that, so you'll see some examples.
Great, thanks.
Okay, so let's take a look at JOT. So on the left here, you can see a JOT. This is an actual sensor. And what this sensor says is we're going to identify unparameterized database queries. So maybe you have a coding guideline or some coding rule, some standard that you have that says, hey, we're not going to use unparameterized queries. We only want to use parameterized queries because they're much safer with regard to SQL injection. That's a reasonable rule, but how do you test it? It's difficult to know if code is actually using that kind of unsafe query. So JOT allows you to measure this really easily. This is a simple example. It just lists the methods that you want insight into. And we're going to exclude prepared statement because that's the safe version. The reason we have to exclude it is because it extends the statement class. And so ordinarily it'd be included, but we want to exclude it here because it's safe. And we're going to capture the arguments to this method, which is just the query to these four methods, which is how you send a query to the database in Java. And the output looks like this. You can see you'll just get all the queries as they come through. You get the exact line of code and the full query. And so it's a good way to quickly identify everywhere in your application that you're using unsafe queries. And you just have to use your application normally. You don't have to know anything about security or testing. You just have to, this will run like during your normal end-to-end tests, especially if they're automated. This will just run in the background and tell you everywhere where you've got unsafe queries. Everybody see what we're doing there? Let me actually demonstrate this so you get a sense of how it actually works practically. So I have this application called Ticketbook here that we're going to use for our example. And in my directory here, I've got Jot. So you just download the Jot jar file. And I've got a directory full of Jots. And if I do an ls Jots, you can see there's a set of Jots in here. We're going to use some of these. I'm going to use this one called untrusted-sql.jot. And the way you tell Java to use this is something like this. You tell Java with this environment variable to use the Jot agent, and then you tell the agent to use this config file. And this usql.jot, oops, it's in the Jots directory. One of those days. Just has the exact Jot we were just looking at. So that's all you need to do to use a Jot. And then you just run this application absolutely normally. Like you just run it. Actually, what happens at the top here as it starts up is Jot kicks in and it instruments those methods. And then the application runs normally. So as I browse around this application, I'll put in dcast. When I go back to my screen over here, you can see here's a query that uses an unsafe method. It's on this line of code. And you can see it's here's the dcast in the query that I typed in. So it's just a fast way of sticking a sensor into your application, just the same way you like use an electronic sensor to put on a circuit board and get data out of the application. So this is a really boring example, by the way, but I'm trying to get you to understand like the capability here. You have the capability to put sensors into any methods you want and see how they're used by the application. And then I'll show you some ways you can use that to analyze a whole application for interesting things. Any questions on that? Okay, let's do something a little more complicated. Let's say we wanted to know about encryption in an application. This is something that we have to test all the time, and it's actually really hard to test for how encryption is done by an application because it's kind of buried in the code. So maybe I want to know that this application is not using any weak ciphers, or it'd actually be better to know it's using all strong encryption ciphers. So this simple Jot over here does two things. First, it puts a sensor into the cipher.getInstance method, which is how you get a crypto algorithm in Java. And it captures the name of that. The first parameter to that method is the name of that encryption algorithm, like DES or AES or one of those. And then the second part of this Jot creates a report. The last one, we didn't create a report, we just outputted everything. But this one actually creates a report, and it says, give me a list of all the ciphers. So that's what it does. And here you can see the output. I won't demo this one because I'm just for the interest of time, but you run it the same way and use the application, and Jot will spit out all the encryption algorithms that are used in this application and the exact line of code where they're used. And you can see this one uses a bunch of weak ciphers like password-based encryption and single DES and things like that, not strong algorithms like AES. So in a matter of minutes, I can test a whole application for something that would have taken me a long time to go figure out, review the code or write test cases. It would have been really hard. The Jot language here is a little more sophisticated. I've got some examples here of what you can do with it. And you can see it allows you to write this capture line. allows you to write a Spring expression here. So you can actually, like, if the way I think about it is you can put this methods tell you where to put the probe, and then the captures tell you like what data to capture from that probe, starting with the first parameter or any of the parameters, the object itself, or the return. So, in this case, the return is a string. So you can call methods on that. You could say, make it uppercase, or you could call other methods on that string. But it's kind of a neat way to gather data out of the application, again, without writing any code. Okay. So this one is really a cool example that I'm super passionate about. I used to spend weeks testing applications access control. It's really hard to do. You have to log on as role A, and then browse around the whole application and try to do stuff you're not authorized for. Then you got to log on as role B, do the same thing. You got to log on as an admin and try all these functions. It's just really hard to understand what you've tested as what role. Well, with instrumentation, we can do this really fast. So here I've got a couple of sensors and a few reports, all in a single jot. What this one does, the first one captures the route. That's your, which URL you went to. The second sensor here gathers the currently logged in user. It captures the HTTP request and pulls out the user. This captures the HTTP request and pulls out the URI. This one pulls out the user. And this last one captures any place this application does an is user in role check, which is an authorization test, and captures the role that's being tested for. Then we put that all together in two reports. The first is a test coverage matrix, which just tells me which users have used which routes, which is interesting to know. Like, I know I tested the architecture page with guest role, but nobody else. Okay. And then this last one is really powerful. This is the access control matrix. And this shows me that these 4 pages have access control checks in them, and it shows me exactly the role they're testing for. Page A tests for role A, page B, role B, page C, role C, and so on. Page E tests for all these 3 roles, and page D doesn't have any access control checks on it, which indicates a possible problem. It also tells me, hey, look, page C, I know it has a test for me being in role C, but I didn't access it as role C. So I probably missed something in my testing. It's a much more sophisticated way to look at test coverage and a kind of really unique way of looking at access control testing. Anybody here ever done any access control testing?
Yeah, I do that quite a bit.
So what do you think of this? Is this something you'd think about using?
Yeah, I think it's pretty cool because I work at a company called Kinetica, and we're we're kind of a GPU based database.
Yeah.
So we do a lot of things with JDBC drivers, ODBC, all the different protocols for all your mainstream databases. And the way most teams would do this is carefully crafted coverage, like test cases and scenarios, making sure but this is really interesting in that it allows you to kind of do, I'll use it really abstract. You can kind of do like observation, exploratory testing. If you have some kind of producer for your test, instead of spending time on like, man, do we have X, Y, and Z in place? Do we have access B scenarios in place? Right. It really gives you the idea of like, let's throw the whole kitchen sink and let's see if we hit all the points, and the ones that I really like it in that it identifies your gaps.
Yeah, I think you nailed it. I mean, this is, just something I don't think people do good access control testing at all. I suspect their coverage is incredibly spotty, and that there's all kinds of, it's kind of a sleeping giant. There's like tons of access control problems sitting out there that nobody's ever discovered because it's hard to do this. But, if you generate this every time you do your, run a build and run your automated tests, and, you can just check the access control matrix in like 2 seconds and see like, oh, it didn't change, or, oh, look, there's a new something changed in the access control matrix. We added this new route, but there's no access control test on it. It's really a powerful thing.
Yeah, the one aspect I like about it that I can see, it identifies gaps, and I can see how this can drive your CI/CD quicker, because sometimes you don't have the time or bandwidth to refactor or scale out your scenarios.
Right.
So as soon as there's a new build queued up, you don't have to wait for the QA team to assemble assets to make sure they have coverage. We can just say, let's run what we have and let's see where the chips fall and identify where our gaps are. So I can see how this could facilitate faster pipelines.
Yeah, that's the whole idea here. And look, of course, contrast comes with like a zillion built-in rules. Jot allows you to create sensors for whatever you want. And it doesn't have to be just security stuff. I can't emphasize this enough, even though this talk is about security. This is a technique that you can use to verify the properties of software, period. Whatever behavior of software you're interested in, if you can, characterize it this way using this language as like, sensors and patterns of execution, then you can use Jot to verify it. I'll give you a couple other examples. Oh, I like these. You can also use Jot to create diagrams. So this is just a couple of patterns that just, you define the sensors in the methods that you're interested in. And then Jot will build a diagram that shows you like, well, here's how those sensors fired when you ran your application. And I think it's really cool. Like, I think of them like if you had cameras set up in your house and like someone walked through the house, you could see the route that they took through the house. Like, oh, they went in the kitchen, in the family room, out on the deck, back in, like you could see that whole thing. And if they were never supposed to go in a certain room, or they went in the rooms in the wrong order, like those are the kinds of things you can verify with Jot. There's another thing you can do, and this is really relevant to you all. You can use instrumentation to fail test cases. So, I wrote an article, you can see the link at the bottom, about developer-friendly security reporting. But like most security reports are awful. They're like, a 300-page PDF file. The better ones are like, Jira tickets and, dashboards and things like that. But actually, we can get it even more natural by building this right into the test suite. This test, this Jot is a thing that just says, hey, I'm going to fail if I ever see any one of these banned methods. Okay, we don't want our developers creating native processes using process builder in Java. That's what's under runtime.exec. Okay, we can put this scope on it that says if we ever see that method get invoked inside a test case, we'll throw this exception. And you can give the developers whatever guidance you want right inside the exception. So here, this test case has nothing to do with security or anything. But we instrumented the environment before we ran the tests so that as this test runs, when this test, when the code that this is testing tries to create a calculator, it like launches the native calculator, Jot will intervene. It'll throw that exception, prevent the calculator from running, and fail the test case. So it's a really nice way to communicate with developers, because now you just turned all your normal test cases into security test cases that developers can just fix as part of their normal development process. Any thoughts on that? Okay, I think it's really cool. Like this capability of like throwing an exception in response to certain program conditions during testing is really cool, because you're like weaving in all this test infrastructure and then unweaving it, and the application can go to production.
So maybe I should have put this in chat, but question for you.
Yeah.
So when you're instrumenting this, do we do it on the developer's workstation, or are we doing it in the CI server, or where are we instrumenting this?
You can do it wherever it makes sense. And I hesitate to tell people where to do it because everybody builds software differently. But some things, it may make a lot of sense to run it right in the developer's environment. Like you could have them, it's like one line of code to add to their test environment. And then you could be in control of the JOTs, or you could let them build their own JOTs to verify stuff. But if you have if you turn your secure coding guideline into JOTs, then it's really easy to enforce your coding guideline. It's essentially turning it into code. People call it security as code, but it's not just security. It's any of your coding patterns that you want to enforce. You can now fail test cases based on violating coding rules, which is just a kind of a cool way of putting guardrails around the process.
Another question, what's the performance impact when you're running this? Several of the clients that I have, they really skimp on the developers' machines.
Yeah.
They're seriously underpowered.
Yeah. The good news is it's almost unmeasurable.
Oh, good.
Yeah, I tried. But the JOTs that I've showed you so far, there's so little code in them. It's like, these sensors are weaving in one line of code that all it does is just snapshot a tiny bit of data out of the application. And in the big picture, it's really almost nothing. But it's an interesting concern. Most people don't care that much about, super high performance in development, as long as it's not, doubling the performance or something. But this is super, super fast.
It's just concerned trying to get the developers to run tests when their machines are really slow. Any kind of tests.
Yeah.
Because the builds are hideously slow.
Yeah.
Then if there's lots of complications into that.
Yeah.
But one of the advantages here is that it's adding such a tiny incremental time because it's instrumented. If they run any tests, they're getting better reporting on it in this case.
Right.
You're piggybacking on the stuff they're doing. Even if that's not enough, at least you're getting more information out of it, making better use of it.
Yeah. So here's just another example, and I'll try to finish up quickly here because I know we're running out of time. But this is more like a runtime example, and this isn't really relevant to you guys doing testing. This is just to show you the power of instrumentation. But I'll demo this one because I think it's kind of interesting. It's also the cause of the Equifax breach you may have read about a couple of years ago. God dang it. Hold on. My machine is actually.
I remember that.
Yeah, so I'll show you this. This is called expression language injection. And I killed my app here. So hold on a second. I'm going to run this without any protection first. And then I'll show you what it's like with protection. So an expression is just a UI technology that people use to build, extract data and put it into a user interface. And here's how it works. So normal data goes right through. You can see Arshan's name just goes right through. If I put 1 + 1, it's just a string that goes through this app and comes out 1 + 1. But if I put the right characters in front, this expression gets evaluated by the server, and you can see it turns into 2. And it's surprising where this turns up. In Equifax's case, it was the user agent header was susceptible to this. If you put the right data into the user agent header, some piece of struts was parsing that and passing it to the expression language engine, evaluating it and returning the value. So smart hackers said, hey, wait a second, that thing's actually running some code. What can I do with that? And it turns out, you can actually do, some math expressions in here. You can put in something like math.max. And you'll see, we're actually evaluating that. And they said, whoa, wait a second, we can call methods? Hold the fort. What if I put in something like runtime get runtime exec open -a calculator. Hopefully I got that right. Let me copy that just in case I didn't. And now it evaluates that expression. You can see I started the native calculator here. If I had done this on a server running this, I would be running native code on the server. And that's exactly what happened in Equifax. It also happened to Atlassian just a couple weeks ago in their Confluence product. Same exact flaw. And it's a really big deal because in one request, I can completely take over the server and do whatever I want to it. I can steal the data, corrupt it, put on ransomware, mine Bitcoin, whatever I want to do. I completely own that server, or I can launch other attacks from behind the firewall. So we can solve this with instrumentation. I can add a jot. I want to show you this this jot. And basically, we're going to detect misuse of this. So I can still evaluate, let me refresh this so I get my page back. I tried that same page and you can see jot intervened and prevented that attack. When we look at that, that jot, we'll see the details. You can see if we try to do things, dangerous things like start a process builder or open a socket from within an expression, that's that scope, we're doing it from within the scope of an expression, we'll throw an exception. And this is runtime protection using instrumentation. So just to try to get you to understand the scope of what we can do here. Any questions on that?
That's pretty powerful.
Really cool.
So there's kind of two categories of technologies. IAST is the term that people use for using instrumentation to detect vulnerabilities. That stands for Interactive Application Security Testing. And with JOT, you can build your own IAST. You could buy Contrast, which is a product that's got a bunch of built-in rules, but you can actually do this yourself and just test for things that you're interested in testing. You can also test for non-security related things, whatever you guys test for all the time, quality issues. Maybe you want to test every web service does the right logging. That's an easy jot. All kinds of stuff like that. Now RASP, we just did that. That's runtime application self-protection. This goes in production. And this is where you're using instrumentation to both detect attacks and prevent exploits. And we just did that with the Struts Equifax kind of breach with expression language injection. So the big picture here is it's all kind of different. Instead of doing AppSec from the outside, it's like this using scanners and firewalls and pen testing to do security, which has a bunch of process problems. And that's why security is done separate from QA, because it's like this whole separate set of experts and tools, and it's just all different. We can do it right in QA. It's embedded in two ways, really. It's embedded into the app. So it's doing security from the inside, which makes it more accurate and faster and so on. But it's also embedded in the QA process, and it's just a part of normal DevOps, which is really different. And that's kind of the change, the big phase shift that I'm seeing here in what DevSecOps is all about. Ultimately, this means your pipeline goes faster. You add a bunch of security as code tests to your pipeline. And we've got a number of big companies now that are committing code, running an automated pipeline that includes a bunch of IaaS testing, and push that code right into production. These are big brand name financial institutions with thousands of applications. They're doing this incredibly fast. So their code goes from dev into prod with security testing in 15 minutes. That's super exciting to me. And as they use more and more IaaS, it gets stronger because they add tests, they add policies, they turn more things into code. and they can go faster and faster. And ultimately, to me, that's the essence of DevSecOps, is enabling companies to push value to production fast. And here's just to let you know, like it's working. We measure mean time to remediate vulnerabilities really carefully, because we think that's the good measure of how far left they've shifted and how good they are at security. This red line is with traditional static analysis, and you'll notice it takes a year to get to close 71% of vulnerabilities in a typical organization. That's way too long. With IAST, we've seen a much different curve. You can see here, all across all of our customers, and that's tens of thousands of applications, you can see they're closing vulnerabilities on average in 7 days, and they get to 90% by the end of the year. We're excited about that. But our best customers, and these are where they've worked off their security backlog, and most companies have a huge security backlog, by the way, thousands of vulnerabilities. When they've worked off that backlog, we can see 75% of vulnerabilities get closed in 8 days. We're really proud of that number. That's a whole different thing than waiting a year to get to that. So, this is showing we're seeing reduction in the number of vulnerabilities that get introduced each month. We call that the vulnerability escape rate as well. That's exciting, because that means to me that learning is going on, and that you're actually getting better at writing secure code, preventing those vulnerabilities from getting introduced in the first place. So look, these are our results for IAST. You can use Jot to improve other kinds of testing as well. And I think you'll see some of the same kinds of results, is that when you get those results back to developers through the tools that they're already using in their workflow, they do a much better job. So with that, I'll wrap up and open it up for questions. I wanted to point you to a couple of articles. If you're interested in learning how to communicate security findings to developers, I wrote a detailed article about that. I think this is mostly for security folks that don't know how to talk to development teams. So, but it has a lot of good information, I think, for testers that want to get into security testing as well. So I'll throw that one out there. The other one is a more big picture article about how security fits into a modern software factory and how we transform it from being a separate piece of machinery to like a core part of the normal machinery. And like the TLDR is that you make it part of your normal software development processes, including regular QA testing. And you can do that with powerful tools like Jot. So with that, sorry for rushing a little bit, but this is an hour talk, and we did it in a little over 45 minutes, I think. So with that, I'd love to open it up for any kinds of questions that you guys might have.
In the example that you gave, I was curious, does contrast provide your own, like, so if you have a customer and they have an application,
yeah,
using your exact same example, some kind of SQL attack.
Yeah.
Does contrast also provide like a database model or a schema? Because it sounds like one of the things is you still need the tester to create the tables, the data, the queries, because the way you were showing with the Jot, which I thought was really cool, is that you still need the data, right? In order for the Jot to give you meaningful feedback.
Yeah,
so I was curious, do you have like data generators?
We don't need the data. Well, yeah, so you're on the right track. We piggyback on normal software testing. So and we don't need like full, what I would call like really exhaustive testing. What we need is more like smoke tests, some simple end-to-end tests to just, fill out forms, exercise APIs, use your client software, but it's just things that you're already doing. Now, they not only do that, but they're doing security testing in the background as well. But you're right. Yeah, you kind of exercise the application a little bit in order for this technique to work. But, it's funny. Most security tools get really terrible coverage over an application. They're only testing a little piece of it, whether it's static or dynamic testing. And so with Contrast, you get really good security testing over the pieces that you do QA testing on. And we have some cool features that let you really understand what you've tested. We have this feature called route coverage that shows you like kind of all the entry points to the application, the whole attack surface, and exactly what you've exercised. So we'll tell you like, hey, you should really go hit those 5 endpoints that you're not testing during your QA process. And that helps customers drive up to 100% security testing, which is something nobody does with traditional tools. It's a great question.
So you could use this either with instrumenting it, either with having your manual testers go pound the keyboards, or you could use, say, your Qs and having your cucumber run it.
Exactly right. Yep. So now you've got secure cucumber.
Yeah, that sounds cool. Sort of on the opposite, and I've just started to look at this lately. But my current client has just started trying to instrument code quality and security quality, and they're using various static analysis tools. And one of them is check marks, and it's producing an awful lot of noise.
Yeah, that's what static does.
I mean, because and recommending
the reason that I created the company Contrast is because I was so fed up with static analysis tools. They generate so much noise. They're not very good at following control flow or data flow because it's super complicated to do it that way.
Mhm.
And this technique is much more effective because instead of trying to mathematically recreate the data flow through an application, which is, massive orders of complexity, instead we just track the actual data as it flows through the actual application. And so it's much more.
You're not attempting to try and do total path coverage. You're just waiting for it to be used by the various test cases that you've already got in place.
That's right. That's right. So the better your test coverage, the better security testing you'll get with Contrast. And I don't think that, static tools are very good at, particularly for injection, where you've got to follow data flow. They're just not.
What I was looking at, it was giving, so the client was actually using prepared statement, question marks everywhere.
Yeah.
And it was giving all of this noise about everything needed to be an SQL procedure. So to avoid the vulnerability, which no, why are we doing vendor lock-in?
Yeah, that's bad advice.
Yeah, I thought it was terrible advice, and I'm no security expert.
I had a question actually with the instrumentation.
Yeah.
In terms, so how the one thing that I think would be a little bit hard in terms of entry would be that the files, or at least the outputs of it, seem to live on the server though itself. Is there a way, or have you considered maybe expanding on it so that the data itself could be exported into other sort of instrumentation, other services that collect metrics and things like that? So I guess when I saw what you were outputting, I guess for me, my first thought was I would love to have that in Prometheus, so that way I actually could get statistical analysis of how often certain types of those were captured at frequency. Is it getting better or worse over the versioning of my application? So I for me, I see that being a very powerful way to enhance that information so it could be more driven for data analysis later on.
Yeah, that is a fantastic idea. I started building it and got a little complicated because it's there's a lot of systems that you want to push data to, but it's really not that difficult to add that to Jot, and it's an open source project, so I'd love some help enhancing it for that. But right now you could push it to a log and like collect the log with a log agent or something. But yeah, like I said, it's not complicated at all. It's just I didn't build it yet.
No worries. I'm not saying why isn't it there. I was just curious if you had.
No, you're right. It's absolutely a use case, and I really did start to build it, and then I was like, I don't know. Do I want to build a dashboard? And then I was like, well, if I choose somebody else's dashboard, like which dashboard should it be? And like, I don't know, like it just gets to be a little bit much.
So Jeff, this seems a lot like aspects, like the Aspect J library and stuff like that. That was development time. And this seems a lot more flexible. It always seemed like it had a lot of promise, but I never quite got using it. But this seems like it solves a lot of the drawbacks because it's runtime, not development time.
You're exactly right. In fact, I was really into Aspects for a while. In fact, I named my consulting company Aspect Security because I think of security as a cross-cutting concern, and that you kind of weave security into an application. And I was like, oh yeah, that's probably the right way to do it. But you're right, like it's mostly just the complexity of writing those aspects and compiling them into the code and like maintaining all that was just too much for that to really ever take off. But yeah, this runtime instrumentation I think is really powerful. It's actually kind of complicated to write an agent yourself, which is why I thought like creating one that's just a simple YAML file that allows you to define your sensors, and the agent takes care of all the bytecode weaving and all that stuff, was like a really powerful way of letting people use this technology. So I hope people will start thinking about ways to apply this. That's a good call. I haven't heard a lot about aspect-oriented programming in the last decade, so you're dating yourself a little bit. I think most of that turned into annotations, right? Like in Java, like there's still a lot of annotations, and under the hood, that's really what it's doing. Is those annotations are actually instrumenting stuff in at compile time, but it's just a better syntax.
Yeah, I mean, that's the big win here, I think, with the, just as you're talking about, the JOT files are just, they're an easy, quick YAML file to specify how the things are going, what it's doing, rather than writing the whole method and everything, which might be, in theory, more flexible, but in reality, just so much to do that you're not going to get around to using it effectively. Right. Whereas the jot makes it, cleaner. Hey, I know I want to intercept these calls. I want to log them. I know I want to take these calls. I want to report on them, that type of stuff.
I haven't done this yet, but you can use instrumentation dynamically. Like you can add sensors and remove sensors from a running application in production. And, one thing that we're looking at how to support is like, what if somebody, wants to gather some data from production that they didn't know about beforehand? Like they didn't have time to write log messages and they didn't build a jot in advance. Can they add a jot dynamic, like create a jot and say, get it picked up by a running application, start pulling data out of the application that, doesn't have any log messages in it, and, diagnosing problems that way. And then once you figured it out, just throw the jot away. You're done. You got it. It's fixed.
Yeah, that would be really powerful. I mean, most of the time we're even struggling with, I'd love to get debug logging turned on, but I don't want to shut down the app to restart it just to pick up that. And
yeah,
you never bother putting in the dynamically changing log levels or,
logging is such a shitty way of getting observability, because you have to know everything that you want to know before you deploy. And usually what you want to know is not in the log. Right. So then you're like, oh, well, I got to enhance the logs and redeploy. And it's just ridiculous. You should be able to just ask the question. I mean, it would be cool if you could just send a message to the app and say, hey, app, tell me what the values of this variable are in this method. for the next 3 minutes. Go. And that's certainly possible with instrumentation. It's, I didn't write the code to take the jots out and add the jots in dynamically, but it's actually not hard. Just haven't gotten to it. It's been busy.
All right.
Do you guys, do some of your customers run these jots in production, or is it more of a dev only kind of process where you would utilize jots?
I honestly don't know if people are using jots in production. Contrast works a little differently. It's similar, but it's much more sophisticated. And so lots of people use contrast in production to identify vulnerabilities and block attacks mostly. But Jot, it's an open source project. I don't really have a good way to know who's using it or how they're using it. I didn't build in any telemetry or anything like that. It's just, it's a simple library that I think people can get a lot of value out of.
Yeah, it looks really cool. I'm gonna check it out right after it's over.
Yeah, let me know if you build any jots. Let me know, and if they're useful, somebody else would probably find them useful. And there's like a directory full of interesting jots in right in the Jot project.
Oh, one last question about jots again. Does it allow you to, it looks like it's a friendly virus. That's the way I view it, as a friendly virus. But does it allow you to inject code real time or make decisions? Or is it primarily just reporting back the data?
You could make it so that you could inject code, but I didn't think that was kind of consistent with the philosophy of just being YAML. So the only thing you can do to change the flow of an application is to throw an exception. That's the only thing that you can do,
Okay.
which is significant. But normally, like most jots are just for sensor read-only purposes. They don't change the behavior of the application at all. They just read data and then that's it. You could, in theory, create an extension to Jot that would inject code into an application, but the complexity outweighs the benefit in my view. I'm trying to hit this perfect middle ground between like writing really a complex instrumentation technology and like getting mass adoption. And so I'm trying to veer towards like powerful but simple.
All right.
But let me know if you think of a great use case. You never know. Maybe I could be talked into it.
Oh, I was gonna say, I think we have time for at least one more question before we try to conclude this event. Does anyone else have any questions for Jeff?
I have one more if there's no one else. Okay, I was looking at Contrast website. So what type of network security do you offer? Like, are you guys doing like malware detection or intrusion detections?
Jesus, something must be really broken with our website. Like Contrast doesn't do any of that. We don't even do network security. We do application layer security. So we only work with application layer technologies. So like you think JVM and up, so everything that runs on that, the app server, the frameworks, the libraries, and the custom code, we secure all of that. We secure serverless, kind of the same thing. Like we do the code and up. We also do this runtime protection where we're protecting the code and up. We don't do anything below that. You still need to secure your containers, your hosts, your networks, malware, all that crap. But there's quite a lot of work to do at the application layer. It's the leading cause of breaches by a wide margin. And it's something that organizations are really not very good at. So, we think we've got by far the best platform to help companies become really good at writing secure code, which they should be. But if our website isn't telling you that instantly, then something's really wrong.
Yeah, originally I thought you
Shine
guys
through
were
right
like,
away.
yeah, I thought you guys were like kind of a network security company at first.
Yeah. Okay. I'll reflect that back to our marketing department. Well, thanks. Hey, you guys, I really appreciate the good questions. It was a pleasure to talk to you. I spend most of my time talking to security people. They're boring and annoying. So this was really great. I appreciate how much you understand about instrumentation and coding. We made for much better questions than I get from the security guys.
I'll try to edit that out. So no one gets offended.
I don't care. They know.
Okay. But I was going to say thank you, Jeff. If everyone could, you can give a silent round of applause, but applause all around for Jeff. If we're in person,
Thank you.
louder. But thank you everyone for joining as well. We will be, making sure we get a copy of the presentation so everyone has the resources out there, and we will also send out a link to once this video is uploaded to our YouTube channel as well. So,
Where is the YouTube channel?
it's on YouTube. If you search for dcast,
Oh, if I just search for dcast on YouTube, I'll find it.
it's there. We're not we're not super huge, but you'll find us. Promise.
It's a great name. I've lived in the DC area my whole life.
We inherited it.
You should bring contrast to DC.
We actually have a huge office in Baltimore, and we do most of our development in Baltimore. We are proud BWI native company, but if you're raising venture capital for a Silicon Valley startup, you kind of have to go have your headquarters in Silicon Valley, unfortunately. That's actually not as true as it was, 5-6 years ago when we started out.
Next time you're on the East Coast, look up dcast. We got to sync up.
Yeah, I live on the East Coast. I live in Ashton, Maryland, just like 20 minutes north of DC.
Oh, okay.
Thank you, Jean, for sharing the YouTube channel.
And Katie, I just shared the
Put in
PDF.
these links.
What did you say, Jeff?
I said I just shared the PDF with you, so you should have
Okay,
that.
perfect.
Send it to-
Cynthia, I'll share the PDF with you. So
Thank
you have it as well. Yeah, of course. Thank you.
Thanks, everyone. Have a great night.
Thanks, everybody. See ya.
Thanks, Jeff. It was really good.
Bye, guys.
Thank you.
Send me questions anytime, or connect with me on LinkedIn.
Why?
Yeah. Click and subscribe.